Hey, thanks everybody. As Tamao said, my name's Clay, and I'm a developer advocate here in New Relic. If you were around for Lou's keynote yesterday, he said that software is the most important creative medium of our time. Fortunately, mobile is a massive part of that story. More and more people are turning to mobile apps when they interface with software, excuse me. And increasingly, all of these mobile apps are connected to services over the network. And I want to specifically focus on that from a performance angle and talk about some best practices when writing mobile apps that communicate to your own APIs or external APIs. One really important part of this talk and why mobile is kind of a special snowflake in this regard is that Google and Apple have helpfully provided customers with very public app stores. Unlike the world of web software, people can leave you a 1-star review at any time. And so it makes having an excellent customer experience even more important. And with that in mind, we're just going to talk about some of the best practices in order to create the best customer experience possible. I like to think there are 3 pillars of app blame, especially when talking about reviews. And there's, of course, the app itself. So that's the code that actually runs on the device. There's the network, everything from the app and to the backend. So the backend, traditionally with a mobile app, yours or possibly a backend as a service provider's, those APIs. And when we kind of drill down into those pillars, the first and most obvious is the app itself. So I'm going to be talking about practices with the code and things that you see quite often that can have a really direct impact from a code level on customer experience. And the first one, and the one that you hear thrown around a lot from customers, are that pages are slow to reload, it takes forever when you're performing some user interaction, or freezes and crashes, of course. And a big part of that is blocking the main thread. iOS and Android apps are multi-threaded. The main thread, also known as the UI thread, is what's responsible for actually drawing the screen, drawing the user interface elements on the screen. And if that thread gets congested, particularly with network I/O, your app is going to suffer pretty badly. So I've written the world's slowest view did load. These are 3 synchronous network operations in the view did load method for an iOS view controller. And this is particularly terrible because the app is going to freeze waiting for all 3 of these operations to complete. In iOS and Android, if this happens for around 4 or 5 seconds, the OS will actually terminate the app. It's pretty obvious when you're doing this for Apple NSURL connection. They make it obvious it's not an async operation, but there are a couple more insidious examples. The most common, and the one you see all the time, is loading data into an image. This data with contents of URL, very nice API Apple's provided for developers, that actually is thread blocking. So if you're not doing that asynchronously and not using library, that's actually going to cause the main thread to halt, especially if you're doing it in initialization functions. Generally, and the really obvious thing here is that you never ever want to block the main thread. And particularly with network I/O, there are some really, really excellent open source networking libraries, and you should really have an excellent reason to not use them. The second part, and this is kind of an old hat if you've done any front-end work before, and that's the request waterfall. Here's one from a front-end application. The idea, of course, is that if you're making multiple network requests, you don't want those requests to block each other. Talking about the same thing with the main UI thread, we don't want to make them all in series. Instead, obvious best practice, we want to make them in parallel. The per host limit has incredibly fuzzy documentation, kind of what is the maximum number of parallel requests on iOS or Android. It tends to be 4 or 5 per host, depending on the OS version or library. The key practice, though, is to always bundle requests. The ideal, particularly for applications that are rendering a list of data, is you want to have a single API request per screen, if at all. And lastly, kind of you got to get back to the open source networking libraries and best practice around them. They're pretty advanced. They understand modern cache headers if they're properly configured, and reading the documentation on those, like AF networking or OKHTTP for Android, making sure they're properly configured has such a massive impact on performance. And lastly, and probably the most obvious thing, is the request size itself, the payload size, and making sure you've enabled gzip compression goes a long way and is pretty straightforward. By my far favorite pillar of app blame is blaming the network, because as a developer, you can kind of just shrug and throw up your hands and say, hey, it's some French network. You do end up getting reviews like this, though, where people are complaining that the app's slow and not on Wi-Fi, or in different languages, or that some obscure cellular provider has just, your app seems unusable. And the lesson or the takeaway here is that the network can just never be trusted, particularly with mobile apps where they are often offline or have minimal connectivity. And part of that story, particularly for apps with a global audience, is that information can't travel faster than the speed of light. If your data center is in Singapore and your customers are in Virginia or vice versa, it has to travel all the way around the world. Traditionally, that would mean you need to build data centers all over the world. Unless you're Google or Microsoft, that's going to be way out of budget. Fortunately, I think CDNs have come a very long way in mitigating some of the downsides. CDNs, points of presence all over the world, that physically move static content closer to customers. Websites and web providers have been using them for years. One recent thing I learned, though, is that for secure connections, SSL connections can terminate at the edge, which means that instead of having to do an SSL handshake all the way across the world, they can actually terminate at the edge, and CDNs can use advanced techniques to keep the connection warm behind their network. So some really interesting stuff happening in the CDN space for mobile that will hopefully get you a little bit farther before you have to build an entire data center. Last CDN point is that you can increasingly use them to cache dynamic API requests as well. The idea there is that for certain types of GET requests, you can also move some of them to the edge, which is pretty interesting. Last point on kind of connectivity and network, always test your app in airplane mode. If you've ever used an app and you've gone into a tunnel, you know a lot of developers skip this test. And lastly, the user experience of your app can vary so widely depending where in the world they are. And recreating bad networks using open source tools and being just aware of different geographical differences in user experience is so important to keep in mind as a developer. The backend is a massive topic, and of course, you can write backend code that's slow. The point I do want to bring up, though, is that people can give you a bad review because the search is slow or it takes a long time to fetch results from the backend. But the interface here, the interface between the app and the backend, is very difficult to change. As a former colleague said, mobile APIs are forever. The idea there, of course, is that these interfaces you create and the mobile APIs, the mobile clients have to talk to, are more long-lived than web applications because we can't force people to upgrade their apps. So if you make a breaking API change, you also risk breaking any old mobile client that's still using that API. The end result is if you're using a third-party API or if you're talking to some service, it's hard to design perfect APIs on your first go. This one in particular is mixing and matching create. The path, it's sending back at 200 when it failed. It's very difficult to understand. It's using all of these non-standard things. Even if you wrote the API yourself or you're using a third-party API, you're kind of stuck with this if you create a dependency between the mobile app you're shipping and the API. So the idea is you want to be agile, you want to iterate without breaking those previous clients. API versioning is increasingly a really nice way to do that. The idea is that mobile clients have a special header. Those headers allow the backend to identify which version of the API to serve. Beyond that, very simple kind of API design advice. You'd be surprised how often non-standard kind of REST-y error codes are used. Sending you 200s when things go well, 400s bad requests, 500s when there's a server error. A lot of API clients do very fancy things with bundling responses in the payload, and you have to kind of parse that, and that just makes your life very difficult as someone who's working with these APIs. Clear and consistent documentation, either externally or internally, can make your life as a mobile developer so much easier if you know exactly how these APIs behave and what they're going to send back if things don't go as expected. I think the key takeaway here, especially as apps are more connected to network services, is that connection, whether it's how you're issuing requests in code, how it's interacting with the backend, or just generally being aware of the networks that exist between your app in the wild in the field and your backend, is just so important and becoming more important when you're trying to build really high quality apps. To wrap things up, no lawyers were harmed in the making of this talk. And thanks very much. I'll be hanging out in the Hacker Lounge if you have any more mobile questions. And thanks for showing up today.